Yeah. Good evening, everyone. Welcome back. Who's there? Santosh. Hello. And other. What are your name, guys? You are not coming with your name still. Okay. So yeah, today's topic, as you can see, we will continue with complex numbers. So today, these are the subtopics we wish to cover or that we should cover. That is polar form, Euler's form, coordinate geometry with complex numbers, cube roots of unit, De Moivre's theorem. Basically, if it's a revision session, you say recap session. So we can cover, but we'll not rush through it. It's better if we can cover up to coordinate geometry, and then we'll the cube roots of unity and De Moivre's part will cover in the next lecture. So yeah, guys, welcome back. Without further ado, let's start. Guys, Santosh, Dosti forever. Can you hear my voice? Is it clear? Yes or no? Give me a thumbs up. Yes, guys, come on. Santosh, are you there? Okay, January 9th. Thank you. Let's see what we have. Polar form or modulus amplitude form. Now, this form is very useful when doing questions, certain types of questions. We'll discuss those questions as well. But please remember, this form is very helpful for us. So, what does polar form mean? Basically, polar form means uh, the form of a complex number in terms of its modulus and argument. I hope you know the polar coordinates. Last time also we discussed the same. So if I write or I try to write the complex number in terms of modulus or argument, it is known as polar form. So how can we write it, guys? See, as we all know, z equals to x plus iy is a complex number, and let's say there is a point P in the Argand's plane that we use to denote it. Then you can see here the length OP, this length, is the modulus of complex number. When we join origin to point P is the modulus. We discussed this last time. What will be the argument, guys? It will be theta. So if we draw perpendicular, then XOP angle, this is the amplitude, or you can say argument. Now basically we just have to write the x and y in terms of r, that is sorry, modulus and theta. So we have done this many times. We have done it in trigonometry also. So what does this brings us to? You can see in this triangle, it's a right angle triangle. If I use sine theta is opposite. What is opposite side? This, which is nothing but y, and this is x. And this is the hypotenuse, which is mod of z. So what will be sine theta? Opposite upon hypotenuse. Then I can write y as modulus of z sine theta. Similarly, what is cos theta, guys? Cos theta is x upon modulus of z. So what is x? X is modulus of z into cos theta. So if we use these both substitutions here, our complex number will now become z equals to mod of z common into cos theta plus I sin theta. Mod of z cos theta plus I sin theta. So many a times we write this mod of z as r. We write it as r. Clear? So this is a polar form of complex number. It's nothing but in terms of modulus and argument. So we saw all this. Yes, we saw x equal to r cos theta. Now this is just a derivation. What is r here, guys? R is nothing but modulus of z. Correct? So let's move to the next. Are you understanding, everyone? JNV ninth. I think you. What's your name, beta? JNV ninth. Yes. Are you able to understand, guys? Hello. Please, you can reply in the chat box. Okay. Thank you. Chalo. Now, there is a way which you will see in many books that cos theta plus I sin theta is generally represented as cis theta. CIS, not SIS. CIS means C for cos into I sin theta. Cos theta plus I sin theta. Right? General notation, many of the times if you find this, it is not a printing mistake, it is not cos theta or it is not sin theta, it is basically cos theta plus I sin theta. And if I see cos theta minus I sin theta, that means the sign of theta is negative. So it will be minus theta. If we replace I with minus I, then what do we have here? Cos theta minus I sin theta. Correct? If we replace I with minus. Now see here, the modification that I just did is, we know that sine of minus theta is minus sine theta. So I can write minus I sin theta by taking minus inside the sign. Similarly, we know that cos of minus theta is cos theta. So basically now the argument of the complex number, which was theta, has now changed to minus theta, right? So let's see what we have next. It is better to remember it the way I showed you. If you like don't remember this way, you can always remember this way by using trigonometry. Correct? And we have seen this in the argument of complex number, that if amplitude of a complex number is theta, then amplitude of its conjugate is minus theta. Let me remind you why. Because if z is a point in the first quadrant, which is x plus iy, or z is represented by p, which is x plus iy, then its conjugate z bar will be represented by p dash, which is x minus iy. X minus iy means what are the coordinates? X comma minus y. Here x comma y. As you can see, the x coordinate remains the same, just the y coordinate changes in sign. That means basically this point is a reflection of this point, right? So if this angle is theta, then this will obviously be minus theta because we are measuring it clockwise direction. Correct? I hope it is clear. So that's why if amplitude of z is theta, then amplitude, or you can say argument of z bar, is minus theta. So obviously, if we add these two, what will we get? Amplitude of z plus amplitude of z bar is 0. Is 0. Now, here is a simple algorithm, you can say, I have developed for easy to understand, for you all to convert the complex number from its normal Cartesian form to polar form. Now it's very simple, guys. If you understand a bit of trigonometry, we know that the argument of a complex number is between minus pi to pi, right? It's a full circle, but it's from minus pi to pi. So using that and some a bit of trigonometry, we can easily we can easily get or easily convert Cartesian form to polar form. See, here I have defined a new parameter, you can see new angle, which is tan inverse of mod y by x. What does mod do, guys? Mod makes sure that value is always positive. So here, if this value is always positive, that means alpha is always in the first quadrant, right? A bit of trigonometry involved here. Please make sure you understand this very clearly, because in many questions we'll be needing to convert Cartesian form into polar form before we can solve it. So please make sure you understand. If you don't, you can write it in the chat box or you can raise your hand. Chalo, let's see this diagram. This Q1 represents quadrant 1. This theta is argument, and this alpha we just now defined, which is always in the first quadrant, which is always in the first quadrant. So what do we have next here? Q2. Now if you see at theta, it is pi minus alpha. Let me make a diagram here to show you that if z, or you can say p, is in second quadrant, then this is the angle and this is the argument, right? But what will be alpha? Alpha is tan inverse of modulus. Modulus means alpha always in the first quadrant. That means alpha is always acute. And if alpha is always acute and this is theta, so this will be the alpha, correct? Because it is always acute, or you can say that alpha is the angle made by this segment, or you can say by the modulus with x-axis, with x-axis. While argument, please listen to me very carefully, alpha is the angle made by the modulus between segment OP with x-axis, but argument is the angle made by this segment with positive x-axis, with positive x-axis. So here this is the positive x-axis and this is the angle made by this segment. Make sure our argument should be between minus pi anti-clockwise. If suppose say P was in third quadrant like this, so I would have measured this way because it is between minus pi to pi, and in this case again angle made by this line segment with x-axis, or you can say shortest angle, or you can say acute angle, right? So hear me out, I am repeating it again. Alpha is the acute angle made by the line segment OP with x-axis, right? And what is theta? Theta is argument of z, which is angle made by the line segment with positive x-axis, which should lie between minus pi to pi. I hope I am very clear about this, guys. Please don't get confused between both, because I have introduced alpha only for this, correct? So yeah, so in this case, if P is in second quadrant, then you can see this total angle is pi. This total angle is pi, and we want this one, so pi minus alpha. So you can guess what will be in the third quadrant. In third quadrant, we are moving anti-clockwise. So this full angle is minus pi. Now in minus pi, we added alpha. So in third, it will be minus pi plus alpha, right? Minus pi plus alpha, or you can understand it as alpha minus pi. And in fourth quadrant, you guys did right, it is minus alpha, right? It is minus alpha. I have understood why the fourth quadrant is minus alpha, because if it's in fourth quadrant, this is the theta and this is the alpha. but since we measure it anti-clockwise, it is negative alpha. Correct? Let's see the next. Theta is known from figure and we can easily find R. What is R? Modulus of Z, which we can easily find by using under root of x square plus y square. Right? So it's easy and very simple to convert it. I hope it is clear also. What do we have next? Euler's form. Now, Euler's form is basically, you can say, exponential form, right? Euler's form, many of the times or many of the books, you will see it is written as exponential form. What is meant by exponential form in terms of E? You know E, right? So basically, Euler, what he did, he converted cos theta plus I sine theta by using the expansion of E, and he wrote it as e raised to the power I theta, right? Correct. So somewhat from there it came. You can see cos theta plus I sine theta can be written as e raised to I theta. So what other complex number will look like? It will be r into e raised to the power I theta. Complex number z is mod of z, which is r into cos theta plus I sine theta, which is e raised to the power I theta. From here, there are certain by using properties of exponential, that is e raised to x into e raised to y is equal to e raised to x plus y. Correct? We can deduce something here from Euler's form. So yeah, chalo. Let's see. Cos theta plus I sine theta is e raised to the power I theta. So if we replace I with minus I, that is if we take the conjugate, if we take the conjugate, then what does it mean? If we take the conjugate, then it will be cos theta minus I sine theta with e raised to the power I theta, right? So these are like both of them are very easy to remember, and obviously guys you need to remember it. So how many forms we have studied until now of complex number? We studied the Cartesian form, which is the basic form. Second, we did the polar form, and third, we did the Euler's form. Now, depending on the question, these three are useful in their own way. Correct? I hope you guys are understanding. Yes, guys, are you there with me? Santosh, JNV ninth, and Dosti Forever. Wow, nice name. Santosh, are you there, guys? Give me a thumbs up. I hope you can see the screen properly. Okay, thank you, guys. Thank you so much. Chalo. So let's move forward. Now, this is an interesting thing to remember. Obviously, guys, we will not be proving 1 upon cos theta plus I sine theta is cos theta minus I sine theta. Why? Because 1 upon cos theta plus I sine theta is 1 upon e raised to I theta, and by exponential property, I can write it as e raised to minus I theta, which, as we know, e raised to minus I theta is cos theta minus I sine theta. That means what I upon cos theta plus I sine theta can directly be written as cos theta minus I sine theta. Correct? Please, here is there is a small confusion for you guys. Many of the times, this property you say that this is 1 upon z is basically z bar. No, guys, this is not true, because in z we have the modulus as well. This is only the theta part, that is cos theta plus I sin theta. It is not modulus of r, modulus of z into cos theta plus I sin theta. So I hope it is clear here. Please don't understand that this is equals to this because your mod r is not involved. So cos theta into cos phi. Now this is interesting, guys. Cis theta into cis phi. Cis theta into cis phi. So what is cis theta? Cis theta is cos theta into cos theta plus I sin theta. Right? It is cos theta plus I sin theta. And what is cis phi? Cos phi plus I sin phi. So instead of using polar form here, we can easily use Euler form and get the result. Right? Because in polar form, it will be very difficult to obtain the result by multiplying and all that. So I can write cis theta is e raised to I theta and cis phi is e raised to I phi. Then we know that if the bases are same, the power will get added. And if we add these powers, we will have e raised to the power I theta plus phi. E raised to the power I into theta plus phi, which I can write it as cis theta plus phi. That means this can directly be written as this. So I hope it is clear that how much useful exponential form is, because whenever we need to multiply 2 or more than 2 or divide 2 or more than 2 complex numbers, it is always better to use which form? The Euler form. Now this is the main use, one of the use which I told you for using complex numbers. I hope it is clear. Whenever we have multiplication of multiple complex numbers or division of multiple complex numbers, it is better to use the Euler form because we can use the properties of exponential. But whenever there is addition and subtraction, we do not use Euler's form, obviously, because addition and subtraction we can directly do by Cartesian form or the polar form. Are you guys here now? Are you able to understand this? Hello, guys. Santosh, I will be giving you questions today to solve. Please try to solve it. Now, here is the second part that we will discuss, which is distance between 2 points. Now, this part comes in geometry with complex numbers, such as coordinate geometry. In coordinate geometry, we saw how to get equation of line, how to write a point, how to get distance between 2 points, how to get distance between point and line. Similarly, how to write equation of circle. In complex numbers, we will be writing all this, but in the form of complex numbers. That means in Argand's plane. So let's see first distance between 2 points. The distance between 2 points is given by our normal distance formula, because z1 xn represents a point on the Argand's plane, and similarly z2 x2 y2 represents another point. So, sorry, what was the distance? Distance is modulus of z1 minus z2, modulus of z1 minus z2. Now it is pretty easy to understand if we understand it vectorically. This we'll be doing many times in complex numbers because it's very useful. If we consider complex numbers as vectors, please don't ever refer this, you will not ever find this in any book, but I personally prefer to relate complex number and vectors because many a times the 2 pages solutions will be solved like this in 2 to 3 lines if we connect the complex numbers with vectors. See, you will see the example here. The actual proof, if you see in any book, The actual proof, if you see any book, you must have done this in class also. Then you will see it is of two, like almost a page, right? But by using vectors, we're going to prove it in this space only this space, two lines. How? So let Z1 and Z2 be any two complex numbers, right? So let's say this is Z1, this is Z2, and this is origin. So if we consider them as vectors, let's say P, let's say this is Q. So this is PQ vector, sorry, OP vector, this is OQ vector. We need distance between P and Q, right? We need distance between P and Q. That is, we need modulus of PQ vector. Now, angle law. What is PQ vector? Modulus of PQ vector. It is OP vector minus OQ vector. Correct? It is OP vector minus OQ vector by using your triangle law. This forms a triangle, correct? This is outgoing, this is PQ, and this will be this. So what is OP vector? Now again replace this. This is mod of Z1. What is OQ? Z2. So we just skip this step in theory, right? Because we cannot, like, there is no logic or there is no proof of writing complex numbers as vectors. But yeah, we just write it for our understanding. As you can see in two lines, I proved that distance PQ equals to mod Z1 minus Z2 by using the triangle law of vector addition. Correct? So yeah, guys, this is it. We'll be solving many questions using vectors in complex numbers, and you will see how enjoyable you will feel after solving. Section formula. Section formula is very simple. Again, you can relate it to the section formula for vectors. Internally में plus sign आता है and externally में minus. That's the only difference. Correct? Consider this as vectors. This is the position vector A and this is the position vector B. Correct? This is the position vector A and this is the position vector B. Midpoint formula. Midpoint formula is same, sum of the both upon 2. So Z1 plus Z2 upon 2. Centroid is also the same. If Z1, Z2, Z3 are 3 points which are forming a triangle, centroid will be Z1 plus Z2 plus Z3 upon 3. I hope you are able to relate it, right? Z1, Z2, Z3 corresponds to point on the Argand's plane. So if Z1, Z2, Z3 are 3 points, that is basically the 3 points are x1, y1 corresponding to Z1, x2, y2 corresponding to Z2, x3, y3 corresponding to Z3. Area of the triangle. What is the area? You can see this. It is similar to the formula. All of them left. No one in the class. Okay. So what we'll do? We'll wait minutes for them to come, or else we'll continue the recording. Okay, guys, we'll wait 2-3 minutes for them to come and then we'll continue. I think there is network issue in their school. So, but yeah, we'll see if they come, or else we'll continue after 2-3 minutes, right? Okay. I hope you have noted down. So let's start again. Midpoint formula. If M is the midpoint of the line joining 2 points, that means we can easily get the midpoint by using the midpoint formula, right? Which is z1 plus z2 upon 2 as same, which is done in coordinate geometry. So it is better if you relate this to coordinate geometry, and it would be better if you can get me the centroid formula. What is the centroid formula? Centroid formula, guys. Still no one in the class? I think we'll wait for some time others to join. Okay, guys, so no one is there in the class. We'll start the area of triangle. We already saw. Now complex slope of line. Now, if you remember the formulae of equation of straight line, and then we'll study the equation of circle, are not exactly the same. There is a slight difference, and you will see what the difference is. What am I talking about? Let the 2 points be z1 and z2. So if the 2 points is z1 and z2, then this will be the slope of line which is joining the 2 points A and B. And in complex numbers, the slope is denoted by W. Right? In our coordinate geometry, we used to denote the slope by M. So here W equals to z1 minus z2 upon z1 bar minus z2 bar. Parallel and perpendicular conditions. Now we know that if two lines are parallel, their slopes are equal. And if two lines are perpendicular, product of slope is -1. But please make sure the same is not true here. I mean, you will see it for yourself. If two lines are parallel, then we'll get the both of the slopes same. That is W1 equals to W2. But if two lines are perpendicular, then we have W1 plus W2 equals to 0. Correct? Please make sure to remember this. Don't get confused with straight line. It is W1 plus W2. So suppose the equation of line is like this, the general equation of line. As we in straight line, we had the general equation as ax plus by plus c equals to 0. Then what was the slope? It was minus coefficient of x upon coefficient of y. Similarly, the general form of straight line in complex plane is this. Then what is the slope? It is minus coefficient of z bar. upon coefficient of z. Make sure here it comes z bar first and then z. So what is the coefficient of z bar? It is a. What is the coefficient of z bar? It is a. What is the coefficient of z? It is a bar. Huh. For please, this is not a printing mistake. A bar. A bar is not a constant. Here, a and a bar are also complex numbers. So a bar are also complex numbers, but a and a bar are fixed complex number like the and z and z bar are general points, right? जैसे in equation of straight line we used to write any general point or any general equation in terms of x and y. So here any general equation will be in terms of z and z bar. So please don't get confused. A and a bar are known quantities. Equation of circle. Center is at z naught. Obviously z naught is the center of the circle and z is the known quantity. So what is the equation of circle? It is modulus of z minus z naught is equals to r. Modulus of z minus z naught is equals to r. This is very logical, guys, because we know modulus of z1 minus z2 is the distance between the points. So if I draw a circle here and take its center here, z naught, then we know that any point z on the circle, if we join it, this is the radius. So what is the distance between center and any point on the circle? It is radius. And how do we get distance? We saw just by using distance formula. That means take the difference of these two. So if we take the difference of these two with modulus, we'll get radius. This becomes the equation of circle with center at z naught. Next, we have equation of circle passing through, or you can say standard form. Like in coordinate geometry, what we had? We had x square plus y square plus 2gx plus 2fy plus c equals to 0. In here, we have this. Again, guys, I'm saying please don't get confused. A and a bar are known quantities. The equation is in terms of z. The equation is in terms of z. Center is at minus a. Center is at minus a. So for you all, this must be like very new. So I would suggest that you all please go through this after this lecture, because it's like we are studying coordinate geometry again, but from complex numbers point of view. So yeah, all these things you need to remember, obviously, guys, to solve the questions. You need to remember all these things to solve the questions. Now, the cube roots of unity. Do we have time? I think it's almost time up. 2 minutes are remaining. But what should we do? Let me just explain the cube roots of unity concept. So, let's say we have the equation x square equals to 1. So, we know x is plus or minus 1. How do we know this, guys? Because it is a quadratic, so we got two values of x. Suppose I say x cube is 1. So then you give me the answer x is 1. This is correct answer, but it's incomplete answer. This is correct answer, but it's incomplete answer. Why? Because here the degree denotes the number of roots. Here the degree was 2, so we got 2 roots plus 1 and minus 1. Here the degree is 3, so we should have got 3 roots. That means we got one of the roots as 1. The other two roots which we did not got were imaginary roots. So how to factorize this? We take x cube minus 1 equals to 0. A cube minus b cube, so we have x minus 1 into a square plus ab plus b square equals to 0. So here we got our one of the roots, which is x equals to 1, and second x square plus x plus 1 equals to 0. Here we'll get two roots, which is two imaginary roots. Why? You can see, because its discriminant delta value b square minus 4ac is less than 0. So this is the basic idea of cube roots of unity. Cube roots of unity means 1 का अगर मैं cube root लूं, then those are the cube roots of unity. Correct? We are studying cube roots of unity because they are very special. Very special, guys. Cube roots of unity are very special. Just a second. The cube roots of unity are very special. Then you will say कि हाँ हम लोग cube roots of unity क्यों पढ़ रहे हैं? Right? Why not cube roots of 2? Why not cube roots of 3? Correct? So because we have very interesting thing about cube roots of unity. So yeah, guys, that's all from my side. Time is up. We will continue with it in the next class. Please, and happy Republic Day to you all in advance, because tomorrow we'll be having a holiday and Republic Day. I hope you enjoy your Republic Day in your respective schools. Thank you, guys. Thank you all. Bye bye. Take care.